As we discussed with the yesterday's class about the triangle of vector addition. Now, here in the today's class, we go with certain numericals on the basis of that by using triangle of vector addition. By finding there is a resultant as well as particle at an angle of 60 degree. Find the resultant force and the corresponding direction at which it is going to be acting. Say for example, see how many forces are given here? Two forces. Say this is 5 Newton and the 7 Newton. And angle between the two vectors is given as 60 degree. Angle given between the two vectors is how much? 60 degree. It means there is an angle is always how much it is? It is less than 90 degree. Less than 90 degree means there is an acute angle will be formed. Acute angle will be formed between the two vectors. Say for example, this is we call according to the question. Okay, we go with according to the question we have. According to the question, what the condition is given? There are two vectors are there. Say this is a smooth surface, or you can also consider there is a table. Okay, we consider there is a table. Okay, it's a table. On the table, we kept a block, certain mass, a block which is going to be kept here. Then there is a force will be acting on this. See, one force is acting at this direction, another is also acting in this direction. Then angle which is made, so this will be the angle. So imagine, for the sake of understanding purpose, there is no diagrammatic condition will be given for this. Just for the sake of understanding, you remember this is the force will be given as F1 is equals to 5 Newton. This is the first force. And there is second force which will be acting on this. Say therefore, the second force acting on this says about 7 Newton. F2 is equals to 7 Newton. It makes an angle theta is equals to how much? 60 degree. Then find out the resultant. How do you find the resultant? So there is a condition which is applied. Then see this will be the resultant. And one more force which is going to be acting over here like this. If you consider, if I go for the accurately diagrammatic condition means, if I go here directly, say this is the force F2 and this will be the resultant R. This is a resultant R. You consider it this way. Then two forces F1 and F2. Then we know that from triangle of vector addition, from triangular law of vector addition, we know the resultant formula. What is the resultant formula you have? R is equals to under root of. What is the formula you have? A square plus B square plus 2AB cos theta. So this is the condition we have. Okay, then here, instead of A, what is given? Instead of A, the value is given here. Just look at now carefully. The value of A is how much it is? Value of A is given as what? F1 is equals to 5 Newton. Similarly, B is equals to how much? F2 is equals to 7 Newton. And theta is equals to 60 degree. These are the given value. Now here substitute. What do you get now here? So there is a resultant R is equals to under root of A square. A square means how much it is? 5 Newton. There is a 5 Newton, 5 square plus 7 Newton. B means 7. So this is 7 whole square plus 2 into 5 into 7 into cos of 60 degree. Therefore, R is equals to 5 5s are 25 plus 7 7s are 49 into, so there is a plus 5 2s are 10, 5 2s are 10, 10 7s are 70. So this is 70. Cos 60. Cos 60 is how much you can get? Cos 60 is 1 by 2. So then divide this. 2 1s are 2 3s are 6. Remains 1. 2 5s are 10. 35. So resultant R is equals to under root of 25 plus 49 plus 35 Resultant R is equals to, if I add all this value, you will get what? There is a value of 25 plus 49 plus 35 is equals to 109 under root of 109. Therefore, resultant R is equals to 10 point. If I remove the root for this, you get 10.44 Newton is the corresponding resultant force is acting there. So this much about the resultant force is acting. Okay. Therefore, resultant related to the given force that we calculated now. Then corresponding angle between the two vectors, how much it will be there? There is 60 degree. That we have to calculate by using the formula. For direction, we know that. Direction, for direction. Okay. For the direction, we know that tan alpha is equals to. Tan alpha is equals to, we are using the formula B sine theta divided by A plus B cos theta. A plus B cos theta. Using this relation now, tan alpha is equals to, tan of alpha is equals to, B value is given. How much is the B value? We have 7. So 7 into sine of theta is 60 degree. Sine 60 degree divided by A is how much? 5 Newton. 5 plus 7 into cos of 60 degree. Cos of 60 degree. Sine 60. We know the trigonometric ratio value. Sine 60 is equals to root 3 divided by 2. Then cos of 60 degree is equals to 1 by 2. Once you simplify all this, you will get tan alpha is equals to, you will get what? 0.7132. 0.7132. Hence, therefore, alpha is equals to tan inverse of, this is 0.71 is the corresponding answer. Okay. Okay, go for the next problem. Here, they're quite similar to this problem, but the value has been changed, where there is a given similar magnitudes. There is a given, the problem is going to be linked with a similar magnitude, but slightly we have to check out what the angle between the two vectors. That we have to be careful in the following problem. We are using the same formula once again. There is no change. You remember the same formula. The resultant R is equals to what we can write? R is equals to A square plus B square plus 2AB cos theta. That formula you remember. And for the direction, we are using tan alpha is equals to, tan of alpha is equals to, we can write as a B sine theta divided by A plus B cos theta. Going for the next problem here. If two equal forces, the next problem, if two equal forces, have the resultant equal to each other, have their resultant, have their resultant equal to either, equal to either what is the what is the angle, what is the inclination between them? What is the inclination between them? Here inclination stands for, it is nothing but what? An angle. Inclination is nothing but what? Finding an angle. So from the question, solution for this, here we have given. The given data is what? So given data, two equal forces. It means there is a two equal forces will be acting here. Say for example, so P is always equals to how much it is? Q. Both are equal. Then you see the condition is given, resultant is equals to either. It means resultant is also equal for this. Two force, whatever is acting on the particle or on the body, that is also equals to the resultant force. Hence, so P, Q are both are same. Then to find here, what to find here? To find corresponding angle of inclination, that is theta is equals to question mark. We have to find there is an inclination is nothing but what? Angle between the two forces which is acting on the body. Then we know that. What the formula you know? The formula is known that what is that? Resultant R is equals to under root of P square plus Q square plus 2PQ cos of theta. This is the formula we have. Then we know that P value is nothing but what here? We can substitute as a P as a Q, and Q is also can be substituted as a R. It means all are equal going to be. Then we can write as a R is equals to under root of this can be written as P square plus 2 times of P dot cos of theta. Then R can be written as P. So this is P is equals to under root of, this is P square plus 2P square plus 2P square cos of theta. 2P square plus 2P square cos theta. Therefore, P squaring on both sides. You can do the next thing, squaring on both the sides. Squaring on both sides. Squaring on both the sides. Then square and root will be cancelled. So this you will get was P square is equals to, this is 2P square plus 2P square cos of theta. This is plus P square. This is also we have plus P square. From RHS to LHS it become minus. Therefore, P square minus 2P square is equals to 2P square cos theta. P square minus 2P square. Here nothing is there. How much? 1. 1P square and minus 2P square is how much? Minus P square is equals to 2P square cos of theta. Then this P square from the RHS and P square from the LHS will be cancelled. Here we have 1. Minus 1 is equals to 2 cos theta. Therefore, we need a cos theta value. Cos theta is equals to minus 1 by 2. Theta is equals to cos inverse of minus 1 by 2. When we will get minus 1 by 2 for cos, this will be theta is equals to 120 degree. Angle of inclination is 120 degree. That is more than 90 degree. That is obtuse angle. In the next question, we have two forces whose magnitude are in the ratio. Two forces. Next question, we have two forces in the magnitude of two forces in the magnitude of 3:5. We have two forces whose magnitude is given. How much it is? 3:5. The magnitude value is given, and which gives a resultant of it gives the resultant of, it gives a resultant of 35 Newton. It gives a resultant of 35 Newton. If the angle of inclination will be, if the angle of inclination will be, angle of inclination will be 60 degree. Angle of inclination will be 60 degree. Calculate the magnitude of each force. Calculate the magnitude of each force. That we have to calculate. Think on the question, then we can go for the solution of this question now. Find the magnitude. There is a magnitude associated with the corresponding two forces. How much it will be there? That we have to calculate. Okay, now solution. Solution for this question. See how much is the corresponding force which is related to this given value is given? That is 3:5. If, I can write as if P is equals to, say, certain unit. So that is 3 times of X. And, because unknown it is, then Q is equals to 5 times of X. I can write as 5 times of X. Then resultant. How much the resultant value is given? Resultant value is 35 Newton. The resultant value is 35 Newton. And angle of inclination, theta is equals to 60 degree. Then we have to go with the solution. From the relation, the resultant formula, resultant R is equals to under root of, this is P square plus Q square plus 2PQ cos of theta. We know the resultant value 35 Newton. This is 35 Newton is equals to under root of P square. So P square means how much we can write? That is 3 times of X whole square plus, then Q square is how much? 5 times of X whole square plus 2 times of 3X into, this is 5X into cos of 60 degree. Cos of 60 degree. Now, you can just solve this condition related to this problem. You can get the condition which is related to this problem as 35 is equals to under root of, this is 3 3s are 9, 9x square plus 5 5s are 25. So 5 5s are 25x square plus, so 5 3s are 15. 5 3s are 15. 15 2s are 30. So this is 30. X into x square into cos 60. As I taught earlier, cos of 60 value is, cos of 60 is 1 by 2. Then substitute here 1 by 2. 2 1s are, 1 is remaining. 2 5s are 10. This is 15x square. So this is 35 is equals to under root of 9x square plus 25x square plus 15x square. We have all the similar terms there. So 9 plus 25 plus 15. You add all the stuff. So 9 plus 25 plus 15 is equals to 49. We get there is an 49x square. So here we get 35 is equals to 35 is equals to under root of 49x square. Now separate the root for this. What you get? 35 is equals to under root of 49 into under root of x square. The square and root will be cancelled. Under root of 49. So this is the square root of what? And a 7. 7 sevens are 49. So this is 35 is equals to 7 times of x. Therefore, x equals to 35 by 7. So x equals to how much we get here? So 7 ones are 7 fives are 35. So therefore x equals to how much we get? There is an 5. So we got there is an x equals to how much is the value we get? And a 5 it is. Then now we can substitute here for to get the magnitude. How much is the corresponding value will be acting there? For value of P is equals to 3 times of 5 is equals to 3 fives are 15 Newton. So P is equals to how much we have? 15 Newton. Q is equals to 5 into 5 is equals to 5 fives are 25 Newton. So it means this is the required answer. In the next question here, we have there is an two forces of two forces equal to P and 2P Newton. That's the next question here. Two forces, two forces, two forces equals to P and 2P. Two forces equals to P and 2P. Act on a particle, act on a particle, act on a particle, act on a particle, act on a particle. If the first be doubled, if the first will be act on a particle, if two forces will be equals to P and 2P, act on a particle, then the angle between the two forces, angle between the two forces is 90 degree. Angle between the two forces which will be 90 degree. Find the resultant. Yes. Find the resultant. As you know very well, the basic formula you know very well, the resultant R is equals to under root of P square means again the two values are given. One is P, another is Q. So this is P square plus Q square means 2P whole square plus 2 times of P into 2P into cos of 90 degree. Cos of 90 degree there. Therefore, resultant R is equals to under root of P square plus 4P square 2 twos are 4, then 4P square plus 2 twos are 4, P into P square into cos 90, 0. Therefore, 0 into anything we get 0. Therefore, resultant R is equals to under root of 5P square. Then R is equals to under root of 5 under root of P square. Square and root will be cancelled. The resultant R is equals to 5 root 5 times of P. This is the resultant. The next one, here we have in the next question. The greatest and the smallest of the greatest and the least smallest of the greatest, the greatest, greatest and the least smallest, least smallest or least resultant of two forces, least resultant, the greatest and the least resultant of two forces, of two forces, two forces, forces acting, two forces acting, two forces acting at a point R, at a point R, point R, at a point R, 29 Newton and 5 Newton, 29 Newton and 5 Newton, 29 Newton and 5 Newton. If each force is increased by 3 Newton, if each force is increased by increased by 3 Newton. If each force is increased by how much? It is 3 Newton. Find the resultant of two new forces. Find the resultant of find the resultant of find the resultant of two new forces, two new forces, two new forces acting at an angle, acting at an angle, acting at an angle, at angle, acting at angle to each other, to each other. So just to think on this problem, slightly has been changed over here. For the greatest and the smallest value of the two vectors, for the greatest resultant and the least resultant, now I can use this. For greatest resultant, we can use P plus Q. Always addition for this greatest resultant will be maximum. And how much is given for this greatest resultant will be 29 Newton. The greatest resultant is 29 Newton. Say this is equation 1. For the least resultant, this is P minus Q is equals to 5 Newton. Say equation 2. Then dividing equation, we get for by using the simultaneous value. So divide equation 1 and 2, or by solving equation 1 and 2. By solving equation 1 and 2, how we can solve this condition? Now look at this. P plus Q is equals to 29. Then P minus Q is equals to 5 Newton. Then what you get now here? So this plus Q and minus Q will be cancelled. This is 2P is equals to 29 plus 5. This is 34. 34 Newton we get. So this is 34 Newton. P is equals to 34 divided by 2. 2 ones are. So then, so remaining 1 it is. 2 sevens are 14. So P is equals to how much we get? There is 17 Newton. P is equals to 17 Newton. Now you read the question carefully. Each value will be increased by how many Newton? 3 Newton. It means 17 plus 3 Newton is equals to 20 Newton is the new force we get. Similarly, now substituting the value of P value in any one of the equation we get. So what is the value of P? So P value is 17 Newton. So this is 17 plus Q is equals to 29. So therefore, This equals to 29 minus 17 is equals to 29 minus 17. How much we get? 29 minus 17 is equals to 12. So we get Q value as a 12 Newton. So 12 Newton. And now this value is increased by how much? 3 units. So that is 3 Newton is equals to 15 Newton is the new force we got. We got new values of P, new value of Q. Again go for the same process of finding the resultant. And angle between the two vectors are given. How much is the angle between the two vectors? The angle between the two vector will be at right angles to each other. It means, see the condition, the greatest to the least resultant of two forces acting at a point on 29 Newton and 5 Newton each other. The force increased by 3 Newton. Find the resultant of two vectors when they are acting at an angle of each other. At what angle they are acting? At perpendicular to each other. Therefore, theta is equals to 90 degrees. We know the resultant. R is equals to under root of, this is P square plus Q square plus 2PQ cos of theta. So cos theta is equals to, how much is given? So theta is equals to, this is 90 degree. Cos of 90 degree is equals to 0. Cos of 90 degree is equals to 0. Substitute here, resultant R is equals to under root of, this is P square plus Q square only. We get because cos 0, 0 is multiplied by anything is 0 only. Then we know the resultant value of this corresponding P square. P is how much? 20 whole square plus Q is how much? 15. So this is 15 square. R is equals to under root of. So this will be 20 whole square. And now we can get this is under root of 625. So if you solve this, you'll get 625. Resultant will be 625. 25, 25 is 625. So resultant is 25 Newton. We got there is a resultant will be 25 Newton. Then find the value of an angle. So tan alpha is equals to, this is Q divided by P. Therefore Q is equals to, 15 Newton. So 15 Newton divided by, this is 20 Newton. 20 Newton. Newton cancel. So this is tan alpha is equals to, tan alpha is equals to 15 by 20. So once you solve this 15 by 20, you'll get 0.75. How it is? 5 3s are 15, 5 4s are 20. So tan alpha is equals to, 3 divided by 4. And this will be equals to 0.75. Alpha is equals to tan inverse of 0.75 is the corresponding angle. So here like this we can solve so many numericals which is related to this condition. So next one, We have there is one of the thing which is related to the vector addition, and here we go with the next one, that is called parallelogram of vector addition, which is going to be quite similar to as that of we can discuss it in the previous class, that is called triangle of vector addition. Similar to this, we have parallelogram of vector addition. Parallelogram of vector addition. So that is parallelogram of vector addition. It's parallelogram. Law of vector addition. Vector addition. Parallelogram of vector addition. So in this parallelogram of vector addition, as we know that in the basic of the triangle of vector addition, what we discussed there, let us consider the two vectors there. The two vectors which will be taken in the same order. The two vectors which will be forms as the two sides of the triangle, which forms as the two sides of the triangle. And the third vector which will be acting like a closing side. The third vector which will be acting as a closing side of the triangle. And that is going to be leads to what? A resultant. Similar to this, now we have to be applying a condition which is related to the law of parallelogram of vector addition. Now, before to go with this, we have to go with the analytical methods over there. So here we are considering the two vectors. So this is the first vector which will be taken in this direction here. So this is the one vector which is going to be taken. Say from this is O, and we consider the point as a O, and this is we consider as a P, OP, and this will be taken as a vector A. OP as a vector. See, OP represents vector A. Similarly, here we consider one more vector. This is OQ. We consider as a OQ. Say this is O, this is Q, and this will represent vector B. OQ represents vector B. Then the resultant which will be drawn, the resultant which is obtained exactly from the center. There is a diagonal which is going to be taken from the same. Yes. And this is called as what? An yes. And now you join this point, you will get called an parallelogram. Yes, this will call as a parallelogram. And now here this is called as a resultant. The resultant is given as vector r is equals to, this is vector a plus vector b. So this makes an angle, as you know very well. So this is the corresponding, the representation of parallelogram of vector addition. Okay. Then the remaining things which are related to the parallelogram of vector addition, the remaining things which is related to parallelogram of vector addition, the statement and the formula which is going to be associated for parallelogram of vector addition will be discussed in the next class. Hope you understand, and we go for the, have any doubt, please. In that fifth question, we consider there is an angle between the two vectors as a 90 degree because those two vectors are going to be mutually, according to the given condition, the force which is acting for maxima or greatest and for the least value. So for least value, for greatest it may be more than 90 degree. But you see here, for the least value, cos of 90 degree, cos 90 degree is equals to how much you get? 0. For that reason, for the least value, we consider as a 0 degree. Okay. Because finding tan alpha will gives you what? And a direction. Finding the tan alpha will gives you what? And a direction. Where R is going to be gives you what? And a resultant. And that is called as a, this resultant is going to be denotes as what? Magnitude. And this alpha denotes what? Direction. Can we
Alpha is equal to tan inverse.
tan inverse can be, so tan inverse can be written as cot. Yes, that's all. So one of our student is asking question. There is about negative sign here. So there is an cos theta is equals to, we got, there is a minus 1 by 2. Cos theta is equals to how much we got? Minus 1 by 2. Then theta is equals to cos inverse of minus 1 by 2. So cos inverse of how much we get? Minus 1 by 2. So cos inverse of 1 by 2, how much we get it is? Minus 1 by 2 is theta is equals to, this is 120 degree. That's all.